Today's lesson is on solving equations using addition or subtraction. So let's start with a definition. Equivalent equations are equations that have the same solutions. We're going to work with several equations today and we're going to make changes to them, but we're going to be sure that we always keep them equivalent. So we're going to do that using two properties. The addition property of equality and the subtraction property of equality. The addition property of equality states that adding the same number to each side of an equation produces an equivalent equation. And the subtraction property of equality states that subtracting the same number from each side of an equation produces an equivalent equation. Both of these properties work. We're going to focus primarily on the addition property of equality because anytime we have a subtraction problem, I'm going to change it to addition so that we can see how we're adding positive and negative integers or rational numbers. So let's look at this first example. Our first example we're going to do with modeling. So I want you to draw this on your paper as I show you some algebra tiles here. So to start with, I have the equation 5 plus x equals negative 3. So on the left side of the equation, I have 5 positive counters. And 1 positive x. That's 5 plus x right here. And that's equal to 3 negative counters. Now, to solve the equation, what we're trying to do is to get x all by itself. Right now, x is with 5 positive counters. So to get x by itself, we're going to add 5 negative counters so that each of these positive counters is canceled out by creating 0 pairs. So now on the left side of the equation, I have all these 0 pairs plus x, which is just x. But our addition property of equality tells us that whatever we add to the left side, we need to add to the right side as well. So I can't just add negative 5 to one side of the equation without doing the same thing to the other side. So I'm going to add 5 negative counters. And then when I look at my solution here, I have x, which is now by itself, only with some 0 pairs. X is equal to negative 8. So that's my solution. And I can put it back into the original equation to say 5 plus negative 8 is equal to negative 3, and that's a true statement, so I know I've solved it correctly. Let's go ahead and look at our other problem here. Our other equation is x minus 2 equals 8. So I'm going to start by converting this to an addition equation. X plus negative 2 equals 8. That helps me see that on the left side of the equation, I have 1x and 2 negative counters. And on the right side of the equation, I have 8 positive counters. So this is x minus 2 or x plus negative 2 equals positive 8. So again, to solve for x, I want to have x completely by itself. So I don't want these 2 negative counters to be with x. So I'm going to add 2 positive counters to cancel those out into 0 pairs. But whatever I add to the left side, I need to add to the right side as well. So now I can see with my counters that x equals 10. And again, I can put this back into my original equation to say 10 minus 2 equals 8, and that is true. All right, now we're going to try solving some equations without using the counters. We'll just go ahead and use some addition to solve this. So I have x minus 5 equals negative 1. I'm going to start by changing that to an addition equation. at least for now, that's going to be our method. So x plus -5 equals -1. So if I want the x by itself, I have 5 negatives here. I need to add 5 positives. And whatever I do to the left side of the equation, to the left of the equal sign, I need to do to the right side of the equation. So now I have -5 plus 5 is 0. So I'm left with x on the left side, and -1 plus 5 is 4. Now, we're going to practice checking each of these equations, so make sure you show this step as well. I'm going to put 4 back into the original equation, and I'll say 4 minus 5 equals -1. That's true. 4 minus 5 is -1. So I'll say -1 equals -1, and then I know I've checked my solution. Let's look at this next example. We have z plus 3/2 equals 1/2. So I have positive 3/2 here. So what I'm going to do is add negative 3/2 to the left side. And then I need to do the same thing to the right side of the equation, plus negative 3/2. So on the left, I'm left with just z. 3/2 and the negative 3/2 will cancel each other out. And then 1/2 minus 3/2 would be negative 2/2 or -1. We'll go ahead and put this back into the equation to check. So I'll say -1 for z, -1 plus 3/2 equals 1/2. And that's true. 3/2 plus -1 or plus -2/2 would be 1/2. So 1/2 equals 1/2. We know we've got there. Okay, last example, we're going to write an equation. So let's read through this problem here, and I'll kind of underline some key details as we do so. A company has a profit of $750 this week. This profit, the $750, that means equals, $900 more than whatever the profit was from last week, and we'll call that P. So as we write an equation here, we're going to say 750, that's the profit from this week, is $900 more than, that would be plus, whatever we made last week, which is P. So just looking at this, I can see we must not have done very well last week, right? P should be a negative number, so we must have lost money last week. So this is our equation. That's our first thing we were asked to do. We were also asked to solve the equation. So to solve the equation, I have 900 here. I can either add -900 or subtract 900. So I'll add -900 to the right side, and then I need to do the same thing to the left. So I'm left with P on the right side of the equation. And then 750 plus -900 would be -150. So since this is a word problem, I want to put units in here at the end. I'll say last week, or P, was $150 with the dollar symbol. All right, so let's go ahead and try a few of these. Don't forget to show your checked work, and I will see you soon.